All right, sorry for the background noise here and there. You hear my kids, you hear the dogs. It's a busy house in the summer. Okay, so for this question, this is from the chapter 15 notes. So for this question, you had to have the balanced equation, which was in a previous slide. And whenever we write these expressions, we always want to incorporate the coefficient that's from the balanced equation. So the rate of the reaction is going to be equal to 1 over the coefficient, and it's going to be positive if the thing is a product and negative if the thing is a reactant. And then you just do this change in concentration of the thing over change in time. So they're giving you the change in Cl2 over the change in time, and they want you to figure out the rate. So really what you need to do is write out this expression in terms of Cl2 and then solve for the rate of the reaction. Now, in this instance, it's just a negative. The rate of the reaction is just opposite of this, but let's show you how that works. So rate of the reaction is equal to 1 over the coefficient, with the coefficient here is just 1, and it's negative because it's a reactant, change in concentration of Cl2 over change in time. So if they tell us that this value is negative 0.091, then the rate is just negative 1 times this value, which is positive 0.091. Now, if we have the rate of the reaction as this value, and we want to determine the rate of disappearance of F2 and the rate of appearance of ClF3, again, we just need to use this kind of formula and include the coefficient. So the rate is equal to 0.091, which is equal to 1 over the coefficient, which for F2 is 3, negative because it's a reactant, and change in concentration of F2 over change in time, which is what they're asking for. Okay, so what we really need to do is multiply the rate 0.091 times negative 3, okay, in order to isolate this as our variable. So that comes out to be negative 0.27, basically, 273, I guess. So the change in the concentration of F2 is 3 times that of the change in Cl2. That should make sense because it corresponds to the coefficients. Okay, for ClF3, same thing, 0.091 is equal to positive 1 over the coefficient, change in the concentration of ClF3 over change in time. This is the thing you're looking for. So to isolate that, you multiply both sides by 2 and get 0.182 for the change in concentration of ClF2. Okay?